All right, guys, here's Dr. Kruse with an algebra video about how to check a table to see if it represents a line, to see if it's linear. I'm also going to show you how to find the equation of a line using your graphing calculator. And once we find the equation, we're going to use the equation to predict the value of y at some point in the future, like 5 years from now or 10 years from now. So let's start with how to determine if something is linear. Well, just graphically, you can tell something's a line on a graph if you just check the slope. For example, this goes up 2 and over 3. That's a slope of 2/3. And from this point to this point, it goes up 2 over 3. And again, so no matter where I check it, between these 2 points, or between these 2 points, or between these 2 points, the slope is always 2/3. That's how you check if something's a line, if something is linear. If the slope stays the same no matter where you check it, then you can assume that that thing is a line. It's not a curve or something else. Same thing for a table. Given a bunch of values in a table, if I had these ordered pairs and I had this xy and that xy and that xy and that xy, if I had those in a table format, I can check it the same way. Just calculate the slope between a couple of ordered pairs and check it in several places, and if your slope's the same, it's going to be a line. We'll say that the values in that table are linear, that they represent a line if you graphed them. We're going to talk about calculating slope in just a second. Remember that sometimes it's called average rate of change, and we'll represent that with ARC. So looking at this table here, I might ask you to test the data in the table, test these ordered pairs to see if it's linear, to see if this represents the picture of a line. If I graphed these, would they all line up? All right, now this is an XY table. I want you to think of them as ordered pairs. So this is the ordered pair 1, 10, like that, and 3, 16, and 5, 22, and 7, 28. All right, so given a table, think of it like this. And now let's go calculate some slope. All right, so down here I've calculated the slope 3 times. First thing I did is I go from x equals 1 to x equals 3. So from the ordered pair 110 to 316, I'm checking the slope between 110 and 316 in the table. Now remember to check slope. This is average rate of change. That's another way of saying slope. And this is a notation that I'm checking it from x equals 1 to x equals 3. So I'm going from here to here. Now remember, slope is the change in y over the change in x. It's delta y over delta x, or the difference in y, difference means subtract, difference in y over the difference in x. So since I'm working with these 2 points, I can start with either y. I chose to start with 16. So I'm going to go y minus y over x minus x. 16 minus 10 over 3 minus 1. Like this, 16 minus 10 over 3 minus 1. Y minus y over x minus x. And I get a slope of 3. Now remember, it'll work if you start with the 10. You can do 10 minus 16 over 1 minus 3. You're still going to wind up at positive 3. Just remember, whatever y you start with on your slope, then on the bottom, you got to start with its partner, x. So since I started with the 16 for y, I got to start with the 3 for x. Now to test this table, we need to check it in several places. So we checked it between these 2 points, and we came up with a slope of 3. Now let's check it between these 2 points, and then these 2 points. And if it turns out it's a slope of 3 all the way up, then we can assume that that's a line with a slope of 3. So let's check the slope from 3 to 5, from x equals 3 to x equals 5. So the average rate of change from 3 to 5 is y minus y, 22 minus 16, over 5 minus 3, 5 minus 3. So y minus y over x minus x works out to be 3 again. Let's move to the slope from 5 to 7. I'm going to do 28 minus 22 over 7 minus 5, just like this. Slope is again 3. Since the slope never changed, since it's all the same, I can assume that if I graphed this table, that it would be a perfectly straight line, that it would be linear. All right, let's do a table that turns out not linear. So I'm going to check the slope from 1 to 5, average rate of change from 1 to 5, y minus y over x minus x works out to be 1. So it appears so far, just from checking the slope from this point to this point, it appears I have a line with a slope of 1. All right, let's check from this point to this point, from 5, 15 to 9, 22. So the slope, or average rate of change, from x equals 5 to x equals 9 is 22 minus 15 over 9 minus 5. That slope is 7 over 4. Okay, that's definitely different from a slope of 1. This is about 1.75, so it's a little steeper. So I kind of already know that this is not a straight line. Something happened. The slope changed from 1 to 1.75. I'm going to go ahead and check that last set of points here and do 23 minus 22 over 13 minus 9. And now I get a slope of 1 over 4. So the slope has changed yet again. It changed from 1 over 1 to 7 over 4 to 1 over 4. This slope is constantly changing. This is some kind of curve. All right. On a curve, if you check the slope, it's constantly changing. It could be as shallow as 0, to as steep as 5 or 6 or 10 or something like that. So this appears to be a description of a curve. If I graph these two and then these two and then these two, the slope is going to be constantly changing. The angle of that line is going to be constantly changing. Something's happening here, but it's definitely not a line. All right, I'm going to show you now how to use your calculator to find the equation of the line for you. All right, so the old way that we learned a while back by hand is to figure out what your slope is and figure out what your y-intercept is. So kind of the long way, using algebra, we said, okay, let's find the slope, and I chose to use the slope from 1 to 2, so I did 11 minus 8 over 2 minus 1. All right, and this is a slope of 3. By the way, we're assuming that this is a linear table. All right, we're skipping the testing part. I'm just going to tell you that these ordered pairs line up. This is linear. So given that this is linear, I can check the slope anywhere, and it's going to be 3. So I check the slope from 1 to 2. It's a slope of 3. Now I need my y-intercept. So since I'm looking for b, I need numbers for y and m and x. We just figured out m is 3. Any x and y in the table will work. I chose to use 2, 11. So I'm going to replace x with 2 and y with 11. Replace y with 11. Replace x with 2. Multiply to get 6. Let's move the 6 away from the b. So minus 6 minus 6. B is 5. So our equation is y equals 3x plus 5. All right. So that was kind of the long way of doing it by hand. Now you can do it fairly quickly on your calculator if you just enter this data into a list, and we'll have the calculator figure out what to do from there. Let me grab my calculator. All right, the first thing is just housekeeping. It's a good idea to empty out your y equals, just so we don't have an old equation in there that's messing with us. So I'm going to press my y equals button, and if there's anything in there, maybe there was a 5x minus 6 in there, we'll just clear that out. Let's just get that out of the way just in case. Okay, now that we kind of did a little housekeeping there, let's go to Stat right here and choose Edit, the first option. And then we have some lists, and this is where we're going to put our x's and y's. Now let's get rid of the old x's and y's, and I usually just do that by hitting the delete key right here. So I'm going to delete, delete, delete until my lists are empty. Okay, now that my lists are empty, I'm going to place the x values in list 1, and I'm going to place the y values in list 2. So from this table, my x's are 0, 1, 2, 3. So let me go over to list 1, and let me just do 0, enter, 1, enter, 2, enter, 3, enter. There's 0, 1, 2, 3 for x's. Let's arrow to the right and put in the y's. So 5, 8, 11, 14, 5, enter, 8, enter, 11, enter, 14, enter. All right, so there we've got our data entered into our table. So start with, just clean out the y equals just to make sure it doesn't mess us up. Go to Stat Edit, enter your x's in list 1 and your y's in list 2. And now we're going to tell it to calculate the equation of a line. This is called a linear regression line. Basically, it's just going to go find the equation of the line for us based on the values that we put into our table. All right, and it's going to tell us the equation in the form ax plus b, which looks a lot like y equals mx plus b. They're just going to use an a instead of an m. So let's go to stat, same place. We're starting over again, stat. Now instead of edit this time, we're going to arrow to the right to calculate. And if you go down to option 4, there's our regression line, ax plus b. I'm going to hit enter. Now I'm on the 83. I'll show you the 84 here in just a second. And I just have to hit enter one more time. And I come up with this table here, this display here. All right, so what is it telling me? It's telling me the equation of a line. It says here, I'm giving you the equation of the line, y equals ax plus b. I'm telling you that the a is 3, so you're going to change the a to 3. And I'm telling you the b is 5, so you're going to change the b to 5. And we wind up right back at our equation y equals 3x plus 5. So y equals 3x plus 5. All right, let me show you what it looks like on the 83, just a little bit different. Or 84 is what I meant to say. All right, so here I've entered the data in my list, same way. I'm going to go stat. I'm going to scooch to the right here until it calculate. I'm going to choose linear regression line. And then it's asking me a bunch of questions, which we're really not going to mess with. It says, hey, do you want your x's in list 1? Yeah, that's where I put them. Did you put your y's in list 2? Yeah. And I'm not going to mess with the rest of it. I just want to calculate. So I'm just going to arrow down to calculate and press enter. And we wind up on the same page. Okay, now where do we go from here? Well, now that we have our equation y equals 3x plus 5, let's put that in our y equals button, 3x plus 5. Now, why do I want to do that? Because I want to go look at the table. I always like to, before I go look at the table, I like to look at my table setup and just make sure nothing weird's going on there. I want to start at 0 and, go up by 1s. So now let's go to our table. And there's the values from our original table. Remember, it was 0, 1, 2, 3. And over here in the y's, it was 5, 8, 11, 14. But now that I've put my equation into my y equals button, I can go further into the future. After 4 years, I had 17 cows. After 5 years, I had 20 cows, and so on. So after you put the equation into your y equals button and go look at your table, you can go in, as far into the future as you want. After 15 years, I had 50 cows, and so on. So you can predict the future with your equation if you put it into your y equals button and go look at your table and just scroll down. You can predict how much you'll have, a certain number of years in the future. All right, so here's one for you guys to try. If you want to just practice one, just pause the video, see if you can put this into your calculator, come up with an equation, put that equation in your y equals, and, have a table ready to go. All right, so hopefully you entered this into your table, into your list, just like we did last time. So stat, edit, put 0, 1, 2, 3 into your list 1, 23, 16, 9, and 2 into list 2, and then stat, calculate, linear regression, and you should have come up with this display right here, which means y equals -7x plus 23. All right, this is the equation of your line. Now notice what's happening here. All right, the number of, let's call these cows, the number of cows I had is less after each year or week or day or whatever goes by. So maybe I started out with 23 cows. That's my initial value. Maybe 1 year later, I only had 16 cows. And 2 years later, I only had 9 cows. And 3 years later, I only had 2 cows. I have fewer and fewer and fewer cows as time goes by. That's one of the things they want you to explain in the homework. They'll ask you about the slope. And they'll say, okay, what's the slope? Well, the slope is the number in front of the x. It's this number right here. And then they'll say, well, what does that mean? All right, well, think about it. If you put this number over 1, If I was graphing this, I would say, well, it goes down 7 steps for every 1 step it goes to the right. And then using words, I would just have to explain that the y's are going down 7 for every 1 year, all right, or whatever they're using for time, for every 1 week or every 1 second. You know, the story I was telling you was that the cows decrease by 7 for every year that goes by. So 16 down to 9, I lost another 7 cows over that 1 year. And 9 down to 2, I lost 7 cows over that 1 year. So when you're explaining what's happening with slope, you're going to say, well, the y value is decreasing by 7 for every 1 unit of time that goes by, in this case, year. All right, now here's a table they give you where they try to, trick you a lot. Maybe in 2012, the tuition at this certain college was $27,870. And in 2013, it was $29,004. Now notice what's happening. It's increasing, 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 and so on. So they have a list of what the tuition cost in a certain year. But this is one of those cases where, when you put this in your calculator, they don't want you to use the actual year. They want you to use the date in terms of years since 2012. So our beginning year, what they want you to use is 0 for that. This would be a year since 2012, so that'd be 1 year later. And this would be 2 years later, and 3 years later, and 4 years later. So let D be the date in terms of years since 2012. Well, 2016 would be 4 years since 2012. 4 years since 2012. One way of calculating that is just taking the year, for example, 2016 minus the beginning year. When you subtract those, you get 4. All right. So we're not going to use the actual date. We're going to use 0, 1, 2, 3, 4 as our x in our list in our calculator. And the tuition will be our y values. So you grab your calculator, you put in 0, 1, 2, 3, 4 in list 1, and you put these dollar amounts in list 2. And you come up with an equation that's y equals 1134x plus 27,870. Now remember to use the letters that they use in their story. So they want this to be T for tuition, and they want this to be D for date. All right, that's the date in terms of years since 2012. So the tuition, the amount of the tuition, depends on what date it is, depends on what year it is. So the tuition in terms of the date is $1,134 each year plus the initial value of 27,870. All right, if we break this down, if we break the slope down, that means it's going up $1,134 each year from 27,870 to 29,004. That's $1,134 increase over 1 year. Think about it as slope. Remember, you always have to explain what's happening here. The slope's 1,134 over 1. So it's going up $1,134 for every year that goes by. And again, it goes up $1,134 for every 1 year that goes by, and so on, all the way up the table. It's increasing at a rate of $1,134 each year. Lots of times they'll ask you to pick out the correct graph. And the easiest way to solve a question like that, where it's a multiple choice, you got a choice of 4 graphs, and which one's the right graph, is just to compare the coordinates in your table to your graph. All right. So if I just go to my graph here, I would look at 0, which is our y-intercept, our initial value, and I would make sure that I pick out the graph that has 0 and is 27,870 steps high. And if that's not enough to pick out the correct graph, if I look above 0 and see if the graph's that high, well, then I go to the next one and I look above the x of 1 and I check and see which graph shows that that is 29,000 and just a smidge more steps high. Right? And usually that's enough. Usually I can look at the y-intercept, my initial value. If I look above 0 on the y-axis, and figure out which one of the graphs is this high, that's usually enough to tell me which is the correct graph. But worst case scenario, maybe that just narrows it down to 2 graphs. Well, then I just have to look at another ordered pair and look at above 1 and see which graph is this high, 29,004 high. And then finally, remember we can use our formula to predict tuition in the future. Our table only goes up to 2016. So what if we want to know what would the tuition be in 2019, 2020, 2021, sometime in the future? So specifically 2019, well, first put your equation into your y equals button. So you enter this into your y equals, and then go look at your table. All right. Now, we're asking about the year 2019, so I can subtract if I want to. 2019 minus 2012 means I'm talking about year 7. Or you can just count up. 2016 is year 4, so 2017 would be year 5. 2018 would be year 6. 2019 would be year 7. One way or the other, you're looking at year 7. So you just scroll down your table to 7 in the X column and go look at what the Y is. And in year 7, which is 2019, the tuition at this college should be $35,808 because it's going up $1,134 each year. All right, let's look at another table, one more. This table, now notice they are increasing 2 years at a time. That's okay. We can have our calculator figure out what this equation is. So in 1985, the number of people graduating high school in millions was 2.83 million. 1987, there were 2.65 million students graduated from high school. 1989, 2.47 million graduated from high school. In 1991, 2.29 million graduated from high school. Notice what your table is doing, what's happening. All right, there's fewer and fewer and fewer students graduating from high school as the years go by. Now, we can calculate, how many fewer every 2 years, but really we want to know how many fewer each year, which is the slope. Let D be the years since 1985, so you can mark this out. We're not going to use the actual date. We're going to let the date be the years since 1985. So 1985 is our starting point, our 0 time. 1987 would be 2 years later. 1989 would be 4 years later, and 1991 would be 6 years later. So these are the x's that you're going to put in list 1. So be careful and note whether they're going up by 1s or going up by 2s or going up by 5s or what they're doing. So the d's we're going to use, the x's we're going to use are 0, 2, 4, 6, and the y's we're going to use are 2.83 and so on. So put these in list 1, put these in list 2, calculate your equation, and you should get y equals negative 0.09x plus 2.83. Using the letters in their story, the number of graduates is depending on what year it is, and it's going down 0.09 million students every year with a starting initial value of 2.83 million students. All right, so make sure you write the equation. Here's the equation that came out of our calculator. Make sure you write the equation using their letters. The number of students depends on what year it is. All right, explain what the slope means. Our slope's negative 0.09, which is kind of an odd number to work with. The easy way to do it is just put it over 1. You can put any number over 1. So this is going down. It's negative. So the y values are decreasing at a rate of 0.09. Remember, we're measuring in millions. 0.09 million students as each year goes by. It will go down 0.09 million students as every unit of time goes by, in this case, years. Let's find out the number graduating in 1992. All right, remember our table just went to 1991, so we want the next year. That would be year 7, the years since 1985. So you can subtract if you want to. 1992 minus 1985 is year 7. We need to put this into our calculator. All right, so put your equation into y equals, put y equals negative 0.09x plus 2.83. All right, set up your table and go look at your table and scroll down to year 7. So in year 7, you should see the y value of 2.2. And what does it mean? Be able to explain what it means. It means in 1992, that's year 7, we expect 2.2 million students will graduate high school.